This video talks about a root of a polynomial. A root of a polynomial is a solution to the equation where the polynomial is set equal to 0. Well, maybe we should review the zero product property. 7 times 0 is 0. 0 times 12 is 0. X times 0 is 0. So what if I have A times B equals 0? You should be able to tell me that at least one of these has to be 0. Either A is 0 or B is 0. Let's talk about something else. The fundamental theorem of algebra states that for a polynomial in one variable, meaning just x's or just y's, the number of roots is equal to the degree of the polynomial. If I have 5x squared minus x plus 10, this polynomial has a degree of 2. It has 2 roots. Now, some people like to say it has up to 2 roots because we could have some double roots or multiple roots. The polynomial x cubed plus 2x squared plus 8x minus 4 has a degree of 3. It has 3 roots. Let's get to work. The polynomial x squared minus 4x minus 21 can be factored as x plus 3 times x minus 7. What are the roots of the polynomial? So we're talking about setting it equal to 0, and it's already factored for us, and I use the zero product property. I have x plus 3 times x minus 7 equals 0. From the zero product property, I do know that x plus 3 is equal to 0 or x minus 7 is equal to 0. These are two linear equations. I will quickly solve these for x. Therefore, the roots of this polynomial are -3 and 7. Now, some teachers may prefer for you to write this in a solution set, meaning that these are the answers to this equation. Be sure to ask your teacher how they would like you to write your answer. Let's try another one. Find the roots of the polynomial y squared minus 2y minus 24. I will set it equal to 0, and I do see that this is a quadratic equation, and we need to factor this. What can I multiply to get -24? Well, I will have a positive times a negative, which means I will be subtracting to get to the middle. I'm going to use 6 and 4. The middle term is a negative, so I will put my largest number by the negative. Let's carry on. I have y plus 4 times y minus 6, and it's equal to 0. I am multiplying two things, in this case a binomial times a binomial. I tell you they're equal to 0. So what do you know? You know that at least one of those must equal 0. So y plus 4 may equal 0, or y minus 6 equals 0. I have two linear equations here that I will quickly solve. So y will equal -4, or y will equal 6. The roots of this polynomial are -4 and 6. Let's keep working. Find the roots of the polynomial y squared plus 10y minus 2. I will set this polynomial equal to 0. I do see that I have a quadratic equation. This polynomial has a degree of 2. So I will factor it and use the zero product property. But wait, this is not going to be factorable. I will have to use the quadratic formula. It does work every single time on quadratic equations. You may want to refer back to this video to refresh your memory on the quadratic formula. but it is negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. And what is my a, b, and c? Well, once I have my polynomial equal to 0, my a is the coefficient of the y squared term, b is 10, and c is negative 2. So let's fill these numbers in. Some of my previous students may be waiting for me to sing the song. I always sing the song when I'm plugging in the quadratic formula. Negative b plus minus square root plus minus square root b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. Negative b plus minus square root plus minus square root b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. Sing it with me now. Negative b plus minus square root plus minus square root b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. And what I always tell my students is, now you know why I am not on Broadway. I can't sing, but I love teaching you. So let's fill in this quadratic formula. So negative b, and b happens to be 10, plus or minus the square root of b squared minus 4 times a times c. And all of that is divided by 2 times a. Let's simplify this. B squared is 100. Be careful with your signs here. Negative 4 times 1 times negative 2. That will be a positive 8. Keep working. And now we need to simplify this radical. I am going to break down radical 108 to 36 times 3. The square root of 36, that is a perfect square. It comes out as 6. We are not quite through. I will have negative 10 plus or minus 6 radical 3 all over 2. And now I can still simplify some more. I can reduce. I have negative 10. I have 6 and I have 2. The radical is just hanging out here. All of these are divisible by 2, so I can reduce. Some people may prefer to separate these and then reduce. But 2 will go into 10, 2 will go into 6, and 2 will go into 2. The final answer is negative 5 plus or minus 3 radical 3. I can write negative 5 minus 3 radical 3, negative 5 plus 3 radical 3. Let's try one more problem. Find the roots of the polynomial x squared plus 8x plus 20. I will set it equal to 0 and I will factor it, but I will have to use the quadratic formula on this because it is not factorable. My a is equal to 1, b is equal to 8, c is equal to 20. The quadratic formula is here. Let's get to work. Negative b plus or minus the square root of b squared minus 4 times a times c, all of that over 2 times a. Now let's get to work simplifying this. 8 squared is 64. Negative 4 times 1 times 20. Be careful with the sign here. This will be a minus 80 or a negative 80. All that over 2. 64 minus 80 is a negative 16. Let's keep simplifying. The square root of negative 16. Remember, that is the square root of negative 1 times the square root of 16. And the square root of 16 is 4. The square root of negative 1 is I. Review those videos if needed, but the square root of negative 16 is 4i. And now do you notice I have 3 terms here? They are all divisible by 2. 2 will go into 8, 2 will go into 4, and 2 will go into 2. The final answer is negative 4 plus or minus 2i. And I can write negative 4 minus 2i, and the other answer will be negative 4 plus 2i.